All right. So the question is, why isn't on number 40? Is it the whole? Why isn't it the whole circle? Right. So here's the deal. There are two things that are going on. I'm going to blow this up a little bit. Actually, I'm going to blow it up a lot. Notice along the x-axis, there are no little tick marks at all, which means you don't actually know what's happening there.
Okay.
So the other side of this is we want our solution to be a function. And if we draw the top half of the circle and the bottom half of the circle, not a function anymore. So it's just going to be the continuous piece until I reach a place where the slope is undefined, and then I have to quit.
Okay.
Okay? All right, what other questions do you guys have? Excuse me.
Can I see? Never mind.
You sure?
I just want to check the answer. There's 20 or 31 and 33 or something.
Yeah, we can do that. Which ones?
31 and 33.
31 and 33 look something like those.
Can you go over 31?
Yeah, I'm good. Thank
Yeah. 31. You said go over 30. All right. So do you have written down what the
y equals dy dx.
dy dx equals y?
Yeah.
Okay. So that means the x just doesn't matter.
Okay.
So whatever, are you sure?
I don't think so.
No, it's
Oh.
2x plus y.
Oh.
I was like, I don't think so. It's 2x plus y?
Yes.
Then I must have read the wrong problem, or because I was so confused.
You're like, mine doesn't look anything like that at all. Yeah. Yours, as you move left and right, looks exactly the same.
Yeah.
Yeah.
Okay.
Okay. Do you need me to do that now or
No, I think I
not so
got
much?
that. Yeah.
Okay. Any other questions?
What about we didn't, the questions we didn't mention?
We're going to go over how to do those today. Okay. Well, let's do that right now then. You don't want that. You want this. All right. So Euler's method. So if you have an initial value problem, you can estimate the value of the solution curve at any value. And when they say value here, what you want to be thinking is at any x coordinate using something called Euler's method. And the basic idea is this. When you were sketching, if you did, the solution curves, let's say that we had a point that was right here, and you were sketching a solution curve. You kind of looked at the slope that was closest to it, and went kind of like that slope. And then when you got to the next one, you're like, okay, it's kind of like that slope. And then when you got down here, you're like, oh, okay, it's going to be close to those, right? So you look at a slope nearby, and you use that slope to help you go a little bit further, and then you keep going, right? And you just, every time you reevaluate when you get near another one. That is the basic idea behind doing Euler's method. What you're going to do is start at the point that's specified. And by the way, this is all non-graphical. You start at the point specified, and you find the slope at that point, dy dx. then what you're going to do is you're going to increase, or in some case decrease, but almost always increase, x by some small dx. That's usually given to you in the problem, or it tells you you're going to go from 3 to 4 in 4 steps. Well, then every step has to be 0.25 because you've gone a distance of 1 in 4 steps. Somehow or another, you'll be able to know what delta x is. And then what you're going to do is you're going to increase y by a small delta y, which is equal to dy dx, the slope, times delta x. So you're going to say, okay, I'm going to use the slope and I'm going to move over to the right a little bit, and how much I move up is going to be determined by dy dx times delta x. The slope times the change in x, because that's really what you're doing when you're doing lines, right? You're doing the slope times the change in x. Now you have a new point that is x plus delta x and y plus delta y. And you do it again. Just like when you're drawing your solution curve in, you go, okay, I'm going to look at the slope at this new point and kind of follow that. There are lots of ways to write this out. I have gone back and forth multiple times. I've been teaching this for a really long time with what is the best way to do it. And I kind of still come back to, although I have a good friend who is like, I hate that way. Here's how I like to do it, because it's important that you show your steps on this. What I do is make a chart. So I'm going to have the x value and the y value. And then I usually leave some space here because sometimes you have to figure out the new y value. And then what I'm going to do is say delta y is equal to dy dx, which in this case is x plus y, times delta x, which is 0.2. I just do 3 columns. Some people do 4. Heck, I've seen people do 5, but I'm like, that's just a little crazy. All right, so my initial point is that f of 2 is equal to 0. So when x is equal to 2, y is equal to 0. Substituting that into my delta y equation, I get that delta y is going to be equal to 2 plus 0 times 0.2, which is 0.4. Then I'm going to increment the x and the y. I'm going to add 0.2 onto x, so that's going to be 2.2. And this tells me how much to add on to the y. I'm going to add on 0.4, 0.4. Yes?
What tells you to add to the y?
I'm sorry? Oh, right here. This is delta y. This is how much y is going to change. So now I'll do the same thing again. So it'll be 2.2 plus 0.4 times 0.2. Let's see, that's 2.6 times 0.2 is 0.52. That sounds right. Yeah, 0.52. So that's how much I'm going to add on to my old y. So x gets incremented, and you could go ahead and fill in all of the x ones. It's going to go 2, 2.2, 2.4, 2.6, 2.8, 3. It tells you right here you want to find f of 3. So now my new y is 0.92. So now we'll do 2.4 plus 0.92 times 0.2. Let's see, that's 3.32. So this is 0.664. If I'm doing that right in my head, feel free to check me. I have been known to, do numbers incorrectly. So when I add that on to my old y, I have 1.56. 584. Thank you. I was like, that can't be right. There should be more decimal places. 584. And you can see it starts to get kind of ugly. So now I'm going to have 2.6 plus 1.584 times 0.2. Okay, I'm going to stop doing this in my head at this point. What does that come out to be? 8368. Thank you. And then when I add that to 1.584, thank you. And then we'll do this one more time. So I have 2.8 plus 2.4208 times 0.2.
1.04416.
Add that onto this. 3.8. 3.4?
It's 1.0.
Oh, 1.0. I was like, something's not right. So what is this? 3.4, 64 what? 96. So this is our approximation. So f of 3 is approximately equal to 3.46496. Now, you may be going, well, this has got to be in the calculator part of the AP exam. It's almost always never, because there are programs you can do that'll do this. They do usually only have you do 2 or 4 steps instead of like this where we did 5, and they always make sure that the numbers are pretty nice.
Okay, that's good.
This one I just made something up and it was like, I don't care if the numbers are nice or not. Okay. But it is one of those things where, I mean, you can do this in a program. And because if you do it right, it'll give you every line. All the numbers are all there and you don't really have to show anything. I mean, you could copy down the output of the program and it would make it look like you were doing it. So it's almost never on the calculator active part of the test. But it's really not hard. It can be ugly, but it's not hard. Those are two different things. Okay? All right, that's it for the lesson. We just needed to finish that little bit up